new node, we have to link the address of the head node and name that new node to a head node. That is the simple point we want to do here to add or insert a new node in the beginning. See, these are the steps we have to do to insert a node at the beginning. Okay. In another scenario, that is also simple one, we have to insert a node at the end. Nothing but we have to insert a node or connect or link a node in the tail part. It can be done in 2 steps. Update the next link of the current tail node to point the new node, and update tail link to point the new node. See, here 2 is given in the tail node. What we have to do is we have to just give the address of the new node to the tail pointer and name the new node as tail. That's all. The insertion of a node at the end is also done, which is very simple. See, general case. In general case, a new node is always inserted between 2 nodes which are already in the list. Head and tail links are not updated in this case. We need to know 2 nodes, previous and next node, between which we want to insert the new node. This can also be done in 2 steps. Update link of previous node to point to the new node. Update link of new node to point to the next node. This is nothing but inserting a node in between the linked list. For that, we want to know where we want to insert a new node. It can be, see, in the given scenario, we can see that new node has to be inserted in between -1 and 16. For that, what we have to do is we have to remove the pointer of -1, address of -1, where the address of -1, the address of 16th node is already stored. Now what we want to do is we want to cancel that link and insert a new node in between and give the address of that new node in -1. And another step we want to do is give the address of 16 in new node pointer. Two steps we want to follow here. First one is we have to remove the address pointer of 16 from -1 and add new node address in -1 and add address of 16 node in new node. These are the 2 simple steps we want to follow to insert a node in between. Hope it is clear. And next scenario is singly linked list deletion. These are 4 cases which can occur while removing the node. We have the same 4 situation, but the order of algorithm action is opposite. Notice that removal algorithm includes the disposal of the deleted node, unnecessary in language with automatic garbage collection Java. Okay, list has only 1 node. The first scenario is if he has only 1 node in the list, then what we can do? It is very simple. We can delete that node. If it is only 1 node, it may be either a head node or tail node. What we have to do is just simply delete that node and remove first. This case we can call it as delete a node in the beginning of linked list. In this case, first node, current head node, is removed from the list. It can be done in 2 steps. Update the head link to the point to the next point to the node and next to the head. Dispose the remove node. See, it is very simple. Let us see that. In this slide, we can see that head node is having the data as 6 and it is pointer address part has the value address of next node as 5. Here what we have to do is remove the address of head node from the next node and name the next node as head, and there is no connection between the 8th node. 8 is the previous head node and the second node, which is current head node. So now what we can do is simply remove the head node, previous head node, which is 8 data part from the singly linked list. Okay, another scenario is remove at the last, deleting an element or node at the end. This is also simple. See here, 7 node, the data node which is containing data part 7 is considered as tail node, which is nothing but does not has any address pointer. Now what we want to do is just move to the previous node, which is 2, and remove the address pointer of next node in that previous node and name that previous node as tail. That's all, and remove that 7th data point node from the list. This is the simple steps we have to follow to delete an element from the end of the singly linked list. Thank you.